If uranium is so important to the future energy, then the next logical question is simple. Where is it? And who actually controls it? From a geological perspective, uranium is not extremely rare, but its distribution is far from even. According to data from the World Nuclear Association, more than half of the world's known uranium resources are concentrated in just three countries: Australia, Kazakhstan, and Canada. However, resources distribution only tells a part of the story. What matters more is production. And this is where things become much more concentrated. In Kazakhstan alone accounts for over 40% of global uranium production. That makes it by far the largest uranium producer in the world. The next largest producer, Canada and Namibia, operate at a much smaller scale. This creates a structural imbalance. The supply of uranium is not evenly distributed across the global market. It is heavily dependent on a small number of countries. But even this is still not the full picture, because in uranium, mining is only the first step. To actually use the uranium in nuclear power, it must go through several addition steps: conversion, enrichment, fuel fabrication. Each of these steps requires specialized technology, infrastructure, and regulatory system. And this is where controls begins to shift from resources holder to technology holders. For example, uranium contains only about 0.7% of the fissile isotope U-235. To be used in most nuclear reactors, it must be enriched to around 3% to 5%. This enrichment process is highly complex and capital intensive. Globally, only a handful of countries have large-scale uranium enrichment capabilities. Russia, the United States, France, and China are among the key players. Among them, Russia holds a significant share of the global enrichment market. This creates a layered system. Uranium may be mined in one country, but processing in another, and used in a third. Which leads to an important conclusion. Uranium supply is not just about resources, it is about a multi-stage, internationally interconnected system. And we can see the implication of this structure in real-world events. After the 2022 energy crisis, Europe moved quickly to reduce the dependence on Russian natural gas. But reducing dependence in nuclear fuel proved much more difficult, because parts of the nuclear supply chain, especially enrichment, remained tied to existing providers. This highlights a deeper reality. Energy dependency doesn't only exist at the resources level, it exists at the processing and system level as well. And unlike oil and gas, nuclear fuel systems are not easily interchangeable. The switching supplier in oil market can happen relatively quickly. The switching nuclear fuel system, however, can take years, sometimes decades, due to technical compatibility, regulatory approval, and safety requirements. This creates what we might call structural dependency. Once a country enters a particular nuclear supply chain, it often remains connected to that system for the long term. From a strategic perspective, this has major implications. The countries are not just competing over access to uranium. They are competing over access to the full nuclear fuel cycles. And that brings us to a key distinction. Owning resources is not the same as controlling a supply. Controls comes from the ability to process, to transform, and to integrate those resources into a functioning system. In many industries, the resources are only the starting point. The real power lies in the system that turn resources into usable output. Uranium is a clear example of this principle. If supply is structured in this way, then the next question becomes even more important. Who actually controls the nuclear fuel system, and how does it translate into long-term power? In the next episode, we will go deeper into the architecture of nuclear control.